Welcome to our conversations about autonomous Postgres. I'm Mark Linster, Technical Fellow at DBtune. Today, my guest is Luigi Nardi, the founder and CEO of DBtune. Luigi started his career in computer science over 15 years ago with a PhD in Paris before going to Imperial College in London as a postdoc, and from there to Stanford University, which I think, Luigi, was a really interesting time to be in Stanford.
Absolutely. Thank you for having me, Mark. By the way, so the time at Stanford was a lot of fun. A lot of the technology that was built back then, now it's really going prime time with all the things that we're seeing in AI and the effect of that in the real life of people.
Yeah. And from there, from Stanford, you took a lot of that, probably inspiration to London University, where you became a professor in AI before then maturing the thoughts to create DBtune in 2020.
Yeah, so my professorship in AI at Lund was a very instrumental moment for DBtune. We were doing research with a small team, and I was doing some teaching as well on the side. But this was really the moment where the technology was getting really mature, and through it's called the professor privilege in Sweden, we were able to incorporate a company in 20 around 2020 very easily from there.
But so, what inspired you as an academic to create a business and to create DBtune?
So I have a mixed background in academia and industry, and a lot of the problems that I research
Mhm.
are inspired by real world problems in industry. So DBtune is a spin-off from Stanford, as we mentioning before, where I was working as a research staff in 2017. Then at that time I was working on new probabilistic machine learning models to optimize computer systems, and database systems were just a very natural fit for this new technology. So by around 2018, I recognized that the tech was ready for prime time, and I built the first software product prototype with my bare hands, and that we called that DBtune. That's how we got started.
That's quite an achievement because everybody should remember that was before vibe coding or AI engineered software development, right? So that's quite something. So I know that Magnus is an advisor to DBtune. How did you connect with Magnus?
So in 2019, I first met Daniel Gustafsson, and then Daniel made an introduction to Magnus. We started discussing, mainly with Magnus, the possibility of applying artificial intelligence to Postgres, which is something I was already working on at that time. I started meeting Magnus regularly and brainstorming all sorts of ideas. I was giving talks in Silicon Valley as well and gathering feedback from some of the companies I was connected with. And the idea of automating Postgres tuning was an appealing idea for many of these companies. And Magnus and I were really discussing the feasibility of the project at that time. In the meantime, I started participating to Postgres community events, met Peter Zaitsev, who eventually became an angel investor and an advisor as well of DBtune. So we had a cool technology and a cool application, but most importantly, we were gathering the team and expertise to execute on this project. And the influence of Magnus was absolutely crucial to the development of DBtune in the early stages.
Great, great. So from your perspective, why is AI-powered tuning the next frontier for Postgres?
So Postgres has a strong foundation, an extensibility mechanism that makes it a platform and a powerful community. It's open source, and I would say that it's the dominant open source relational database to date. So while Postgres is already adopted by large organizations and used for critical applications, the process of tuning Postgres is still a tedious process, right? So on one hand, large enterprises have many Postgres instances that we count in hundreds, if not thousands. And tuning those instances is a lot of work, and it requires skilled database administrators to do it. It is, generally speaking, hard to find that expertise at that scale. And this is an issue that we need to solve. On the other hand, smaller companies use things like Django and ORMs to manage the databases. And it's often developers and platform engineers that manage the instances. So they don't have a lot of visibility on how this is done. So if you automate performance tuning with some form of AI assisted engineering tool, you can help all those companies, small and large, and make them worry less about their Postgres instances, right?
Yeah. But now, I mean, we've had PGtune, for example, for quite a few years, right? And it really works, right? I mean, a lot of people use it, swear by it. Some of its rules have been implemented by the DBaaS providers, etc. Why do we need AI, agentic AI, to do better? I mean, why can't we just use those rules?
The solution space is too vast to be represented with a set of rules. This is why a learning-based algorithm needs to be used. Okay, so PGtune is a successful example of a rule-based tuning system. I personally love it, and I think that everybody should use it. But by refining PGtune's recommendations, we see a lot of additional performance, especially in production systems that run complex environments, right? This is because PGtune cannot recognize patterns in the workload. In
Ah,
other
okay.
words, there is no, abstraction of the workload. And it is challenging to solve a complex combinatorial optimization problem, which depends on the workload and the environment. So AI obviously is best suited for tackling multidimensional optimization problems. For example, a common modus operandi for tuning parameters in the server of Postgres is for DBAs to go on a sequential scan of these different parameters and tune each one at a time. But this is not how it works because you need to tune multiple parameters at the same time if you really want to reap the benefits of the tuning. Think, for example, about random pitch cost, which is a disk
Yeah.
and the planner parameter and
Mhm.
the parallelism parameter, like
Mhm.
max parallel workers per gather, for example. Those two parameters really go hand in hand because if you're
Yeah.
trying to get a sequential scan and those sequential scans are highly parallelizable, then you can tweak as well the parallelism to achieve, the reaping, this multiplier effect through these two parameters. So this is a simple example, but there are many more out there.
So basically, the optimal tuning is not template based like what we do in PGTune, but it is really depending on the details of the workload, right? Where you really need to look at, okay, how many parallel workers would you optimally use with the current hardware setup to achieve the goal, right? Okay, that's very interesting. Now, today, I mean, we're all talking about managed services, right? AWS RDS, Azure Postgres, Alloy DB, Ivan, whatever. I mean, in the age of managed services, do we still need database tuning?
Yes, because database as a service providers today rely on a SKU-based, predefined set of parameters.
Uh,
Okay, and so this is very similar to what PGtune does, right? So this
mhm,
means that the parameters relate to the size of the instance, but they don't adjust to the workload.
uh, mhm.
Additionally, in the cloud, things move up and down more regularly, and the degree of variability is higher, right? And this is by nature of the cloud. And so tuning more frequently can be a real advantage in those environments. So in the cloud, it is very, very tempting to solve performance problem by just upscaling, right? You make the problem go away. It's done in 20 minutes, but of course, it has a very long-term cost. And in practice, we have seen even ourselves, we've seen that you can achieve the same without upscaling by tuning the instance. So you can see like a 10x improvement in performance and a 50% CPU usage reduction in real world AWS RDS production systems, for example. And of course, at the AWS users are not the only ones, to benefit from this type of autonomous tuning, right?
Okay. Now we're talking a lot about tuning. You just mentioned the word autonomous tuning. I mean, the real dream, I think, is autonomous database, right? Where the database just runs and, DBAs maybe every once in a while have to look at it, but it doesn't deserve the continuous attention that we used to give databases, right? I mean, is autonomous Postgres or self-driving Postgres, is that realistic in the near future?
Self-driving databases, autonomous Postgres, these are all really, really fascinating topics. I think, we are really committed to work on. We've been focusing on a smaller part of the self-driving database framework, which is autonomous tuning. But fundamentally, I think that this vision is possible. Okay, so I think we should really be optimistic about this. And in industry, we have some examples of clear success stories with respect to
Mhm.
self-driving systems. So self-driving cars, while they're quite different from database management systems, I think there are a lot of similarities there. And the project at the beginning, when I was in academia back then, there was a lot of discussions on, the quality of the computer vision systems to do this and so on, the sensor fusion stuff. And it was fascinating. Many people thought that it was really hard, and other people thought that it was impossible. And, fast forward, 10, 15 years later, and now this is a solution that's commercially viable. And if you think about that, the first project was the NavLab project by CMU, and this was a 1984 project, right? So it took a long time. And of course, Waymo went a little faster than that. I think they started probably working on this probably 15, 20 years ago, and now they have fleets in multiple cities in the US. So this is certainly possible, and I really like to inspire myself from examples in engineering that have worked. In some sense, the idea of autonomous Postgres is really to, automatically achieve, some sort of transformation from point A to point B in a effective, efficient, and safe manner, which is, kind of the description for self-driving cars as well.
Great. Interesting stuff. So what's next for DBtune?
Mark, look, I'm extremely excited about what we achieved so far. This is absolutely exciting. So we understand though that the scope is bigger, and what we currently do is not enough to achieve this vision. And so we have defined a roadmap to tackle the other important problems for autonomous tuning and self-driving databases. We need to add tuning automation to classical problems like vacuum indices and tuning at the level of the sessions and tables as well, but also to newer problems like asynchronous I/O, for example, and other modern mechanisms that are part of the
Mm.
current Postgres stack, right? In the meantime, we are really enjoying seeing DBtune used in many critical systems in production and learning every day from the many challenges that our users have in other areas and managing their databases. So there is a community here, by the way, so which is available for anybody. So give it a spin and let us know how it goes, right?
Great, great. Well, thank you. Thank you, Luigi, for the conversation. Listeners, you can send us email to autonomouspostgres@dbtune.com for any suggestions for future interview candidates or questions that you may have, or specific features that you would like to see in DBtune. So thank you very much, and see you soon.
Stay tuned.
Thank you.